carrying on from our previous video on the product rule, we're now going to discuss the quotient rule. Now, the quotient rule comes from the term quotient, and that means when you've got something that divides by something, so in this case u divided by v as an example, then the result is a quotient, so hence the name. Now, if you can do the product rule, then you can definitely do the quotient rule, because they're practically the same kind of procedure, just slightly different variations. We've got a minus sign in the middle instead of a plus sign, and then we've got this term here, this dividing everything by the v squared. It's all straightforward. The only way to really learn it is to do an example or two, so that's what I'm going to do. So I'm not going to labour it any more than that. Let's get on with a couple of examples. Okay, so let's have a go at an example. So let's have a go at this first example here, the example 1. Now I've written I've printed up here the formula, the rule, so we can refer to it. Just shuffle it up a little bit, and we're going to apply it to this here. So I'll just shuffle this over to the left, give myself some space, turn the pen on. Okay, so I'm going to define that the top is u. Do better using the pen, I think, than the mouse. Okay, u, and the bottom bit here is the v. With the product rule, it didn't matter which way around you did this, but it does matter very much with the quotient rule. We've got to define that the top is the u and the bottom is the v, assuming that the formula is this way around. Obviously, if we switch them around, we could switch the terms. Okay, so what do we do? So we've got dy over dx equals, so we do the derivative of this is the top by u, this is the bottom. We're doing a divide, so we're using the quotient rule. So it says that v comes as it is, nothing done to it. There's no d in front of it, dx underneath it, so it's just as it comes. So it's purely 2 cosine x. Okay, next term du dx, so the multiplying, so it's the multiplying the derivative of u. So take the 4 down to the front, multiply it in, standard procedure, take 1 from the power, we now have 3. Then the next part is we have a minus sign, we have a minus, then we've got u as it comes, so it's just 3x4, so nothing done to it, times the derivative of the bottom, dv dx. So the derivative of 2 cosine x is going to be a sine, so we need to put it in brackets because it's a minus sign. Don't forget the 2, sine x, like thus, all over v squared, which is 2 cosine x squared. So I'm going to put it, this time I'm going to just put it in brackets and square it. There'll be a little bit more about that in the next example. Okay, so let's moving on. So the second example, example number 2, let's have a look. So this one is, let's say it's intriguing, let's say it's interesting, because it's sine over cos. Now, if you know your trig identities, you will know, let's get my pen on, that sine x divided by cosine x is identical. You could say is equals, but we tend to write identical with 3 lines. It means it gives identical results, left and right hand side, to tan of x. Now, if you look up tan of x in your table of derivatives, you will find this. dy dx of tan x gives us, it's a not so common term, sec squared x. Now just a heads up, sec means 1 over cosine. Okay, and obviously sec x squared just means, let's put my x in there, just means that this is squared, like that. Okay, so that's identical to that. Okay, more on that to come. Let me just move things up slightly. Okay, so I'm going to do the derivative of this using the quotient rule, and I should get this as a result. Let's find out and see what happens. Oh, the suspense. Let's have a look. Back to my pen. Okay, so dy dx equals, so we've got, so the top is the u, the bottom is the v. The formula says we start with the v as it comes. So we've got cosine x, nice and easy, times the derivative of the top term. So the derivative of sine is simply cosine x. So we've got cosine x times cosine x squared, in other words. Then the next term is a minus, or the next function is a minus. Then we've got the v as it comes, u as it comes, sorry. So that's sine x. Then we've got the derivative of cosine x, and remember it's got a minus sign, so we put it in brackets to make it clear that it's multiplying it and not subtracting it, and that gives me sine x squared. So we've got sine x times minus sine x. Okay, all divided by cosine x squared. I'm going to write it like this for now. Now that looks nothing like that, though you can see a hint of where we're going with that cosine there. Okay, let's rewrite it. So what have we got? We've got cosine x times cosine x. So I'm going to write it like this. If you don't understand what I've done there, just bear with me, I will come back to it. Here we've got a minus sign and a minus sign. Bring this minus sign to the front, so they're going to multiply together to make a plus. And now we've got sine times sine, so sine x squared. Now you might not be familiar with this terminology, but this, putting the 2 here just simply means cosine x times cosine x, and this, and similarly this is just sine x times sine x. So it's another way of writing it, it's another convention. So if you've not seen that before, you have now, and it's worth seeing the video just for that, to be honest with you. You need to know that. Okay, so it's all over. And back to my pen, all over cosine. I'm going to write this like this, as per convention. Right, still doesn't look like that though, does it? But if you know your trig identities, you'll know there's another one that says that cosine x squared plus sine x squared is equal to 1. Okay, so that means that this is all equal to 1 over cosine x squared. Hey presto, as you now know, that is equivalent to that. Sec x squared. So we've proved it, and that's the beauty of maths, you can prove things. So let's now take a look at a real world example. So those of you who've maybe seen my video on the product rule will maybe recognize this here, this formula. that we did a differentiation on it using the product rule, because this multiplies this, so we have to use the product rule, and we ended up with this as the final result, as a derivative of it. Okay, and what I'm going to do now is, what I've done here is, because this is a minus sign, and because of the laws of indices, I can bring it to the bottom. So that's what I've done there, brought it down. We now have a quotient, or the result would be a quotient, so I need to use the quotient rule. So that's exactly what I'm going to do. Now, if I do this correctly, and if everything works as it should, then I should get the same result. Let me just shuffle this up a little bit, give myself some space. In fact, let's remove the original results so I can check I'm not cheating. Shuffle this over a bit more. Okay, let's have a look. So what we're going to do is use the quotient rule and apply it to this here. So it begins with V. So V is this term with nothing done to it. So we've got dy over dx equals V as it comes, so simply that, times the derivative of u with the top term. So we've got there, so the 2 pi f is going to come out, so we're going to have a, and the 2 pi f comes out. Then we've got cosine, the other function if we like, 2 pi, and the stuff inside the bracket stays the same as always. Nothing's done to that. Then we've got a minus sign. Then we've got u. Sorry, no we haven't. Let's get rid of that. Yes, we've got u, but it's just as it comes. So a sine 2 pi frequency time those brackets, and then we've got the derivative dv dx, so that's the derivative of this, the bottom term, which is k e to the kt. Okay, then all that is divided by a bit lopsided, but it'll do, v squared. So that's e to the k t, and all that's squared. Okay, so it's complete, it's done. We can get an answer from that. We can put in any value for time that we want, and it will give us the gradient. So it will tell us the velocity from this. Remember, this S is for displacement, so it will give us the velocity. We could differentiate it again if you've got nothing better to do, and it will give us the acceleration at any point in time, but I think we'll stick with this for now. Okay, so obviously it doesn't look quite like it did last time, but let's see what we can do with it. If we do a bit of simplifying and rearranging, so what I'm going to do is I'm going to take the EKT outside of these two terms as a common factor, like thus, bracket a 2 pi frequency cosine pi ft minus, just going to leave a bit of a gap there, sine, for the reason that will become obvious in a second, 2 pi ft, and then this k I'm going to bring to the front here. Okay, and then the EKT has come out here as a common factor, and if I divide the lot of it as before by r e to the kt all squared, squared, So we're still not there, but let's have a look. We can simplify this because that there will cancel with one of these on the bottom. So I'll get rid of that 2 because there's now only one of them. Okay. Right, now I've got that, I'm going to shuffle up a little bit. Give myself some space. Still not the same. If you remember the result before, we didn't have a denominator. But because this is a common denominator between these two terms, that term there and that term there, I can split it between the two. Because it's on the bottom, I can bring it to the top and it become minus. And you can probably see where this is going now. So that means we end up with a e to the kt for this term being brought to the top, which means that that has to be a minus sign. So don't forget that, that's very important. That makes all the difference in the world. 2 pi cosine 2 pi ft, close bracket, minus, and then this time we've got k, expand that a bit, ka, brought this bottom term up to the top, minus sign, don't forget the minus sign. Then we've got the sine two pi, might be starting to look familiar to those of you with a good memory. Okay, let's have a check. I'm just going to zoom out a little bit so we can see more. Shuffle things a little bit. If I bring that down, let's have a look at what we've got. You can probably see it straight away, but here we've got ae to the minus kt, which is the same as that there. Then we've got this sine 2 pi ft. Sorry, I'm on the wrong bit here, rather. Helps if you use the right bit. This bit here, which is the same as this bit here. And then we've got the minus sign, check. And then we've got the kae kt, check. And then we've got a sine function at the end. Hey presto, it's worked. I love it when a plan comes together.